Hi guys, today we're gonna solve some AP exam pre-response questions involving solving differential equations using separation of variables. So let's get started. Our first question is question number 6 from 2010 AP exam. So in this question, we're gonna focus on sub-question C, which is about differential equations. It says find the particular solution f of x with initial condition f of 1 equals 2. So we are given the differential equation right here. You're just going to go ahead and solve it for f of x. So dy over dx equals x times y cubed. First of all, we need to separate our variables. Y is going over here. Dx is coming up here. So it's going to be dy over y cubed equals x times dx, right? Now I go ahead and take the antiderivative of both sides of the equation. You guys can rewrite this as y to the negative 3, and then remember the general power rule. You increase this by 1 and then divide it by the new exponent. So it's going to be y to the negative 2 divided by negative 2 equals x squared over 2 by the power rule again, plus c. Okay? Let's continue and solve it for y with the given initial condition. This is going to be negative 1 over 2y squared equals x squared over 2 plus c, right? Let's plug in the initial condition. You don't have to wait to simplify it to plug in the initial condition. So this is going to be 1 over 2 times 2 squared equals 1 squared over 2 plus c, as you know. So this is going to be negative 1 over 8 equals 1 over 2 plus c. So if you subtract 1/2 from each side, you're going to get your c, negative 5 over 8. We write down our solution with c now. So it's going to be x squared over 2 plus we write down our solution with c now. So it's going to be x squared over 2 minus 5 over 8. So I want to get rid of this 1 over negative 2 here. So I'll multiply everything by negative 2. So it's going to be 1 over y squared equals negative x squared plus 5 over 4, as you can see. So you want this to be flipped. So I'm just going to flip each side of the equation. So it's going to be 1 over negative x squared plus 5 over 4. Then you take the square root of each side. So it'll be y equals square root of 1 over negative x squared plus 5 over 4, right? This answer is enough for your AP exam. But if you want to go ahead and simplify it, your simplified version will be y equals 2 over square root of 5 minus 4x squared. Okay, so let's move on to the next question. This question is from 2008 AP exam. So find the particular solution f of x to the differential equation with the initial condition f of 2 equals 0. So let's get our differential equation here, y minus 1 over x squared. Let's separate our variables. Y minus 1 is going down here. And then dx is coming over here. So then we're going to take the antiderivative of each side. Those are all denominators, refers to ln, absolute value of y minus 1 equals negative 1 over x plus c. You guys can just rewrite this as x to the negative 2 dx and then apply the power rule. So let's come over here. We're going to convert this to exponential form. So it's going to be y minus 1 equals e to the negative 1 over x plus c. So remember, in exponential functions right here, e to the c will be as same as, let me take a note here, so e to the c will be as same as a constant k. So that's why I'm just gonna come over here and write as k times e to the negative 1 over x. And then it becomes y minus 1 equals k times e to the negative 1 over x. So let's go ahead and plug in our initial condition, which is given f of 2 equals 0 right here. So it's going to be 0 minus 1 equals k e to the negative 1 over 2. So negative 1 equals k times e to the negative 1 over 2. Divide each side by e to the negative 1 over 2 will give you the constant here. So this is as same as negative e to the 1/2 equals your k or c, whatever you call it. So let's go ahead and write our solution now. So this is going to be y minus 1 equals negative e to the 1/2 times e to the negative 1 over x. I just placed in right here in this function. So this is as same as y minus 1 equals negative e to the 1/2 minus 1 over x, right? Combine the exponents. So it's going to be y equals 1 minus e to the 1/2 minus 1 over x. So this is going to be the particular solution for the given initial condition. Let's move on to the next question. This is question 5 from 2006 exam. Find the particular solution to the differential equation with the initial condition f of negative 1 equals 1 and state its domain. Don't forget to state its domain because it is asked from you. So let's write our differential equation here again. 1 plus y divided by x. So separate the variables. It's going to be dy over 1 plus y equals 1 over x dx. So just go ahead and take the antiderivative of each side. So this is going to be ln 1 plus y equals ln x plus c, right? I go ahead and write this in exponential form. So this is going to be e to the ln absolute value of x plus c. Now you know it, e to the c is same as a constant. I'm just going to call it c, okay? You can call it k or another constant, e to the ln x. Then I just see that this is going to be 1 plus y equals c times e to the ln x. Actually, instead of e to the ln x, we can just write absolute value of x. Remember, note it here, so e to the ln x, it is like e and just ln kind of cancel each other. So this is just going to be the x here, absolute value of x here. So let's go ahead and plug in our initial condition, f of negative 1 equals 1. So right here, this is going to be 1 plus 1 equals c times absolute value of negative 1, so 2 equals c. Then we can just write our solution, 1 plus y equals c times 1 plus y equals 2 times absolute value of x. So y is going to be 2 absolute value of x minus 1 when x is less than 0, as you guys can see here. So x is a negative number. Or you can just say that this is negative 2x minus 1 when x is less than 0. Both are okay. Let's move on to the next question. This is question number 5 from 2011. Find the particular solution w to the differential equation 1 over 25 w minus 300 with initial condition right here. So let's separate our variables first. Let me write the differential equation here. 1 over 25, so w minus 300. So what happens here, I'm just going to take this w minus 300 down here. And then 1 over 25 dt right here. Then we just go ahead and take the antiderivative of each side of the equation. As you guys can see it here, so it's going to be ln w minus 300 equals 1 over 25 t plus c, right? And then we just write it down in exponential form. It's going to be e to the t over 25 plus c. So as you know, this is as same as c times e to the t over 25. Now let's plug in our initial condition right here. So it'll be 1400 minus 300 equals c times e to the 0. So 1100 is going to be our c. Then just write your solution with the c constant. So this is going to be w minus 300 equals 1100 e to the t over 25. So w equals t over 25 plus 300. Okay, this is going to be your answer. So let's move on to the next question. Question number 6 from 2013 exam. Find f of x particular solution again to the differential equation that passes through 1, 0. So let's write our differential equation here. So this is going to be e to the y times 3x squared minus 6x. So let's separate the variables. So it's going to be dy over e to the y equals 3x squared minus 6x dx. Now let's take the antiderivative of each side of the equation. You guys understand this is just e to the negative y, right? And remember the derivative or antiderivative of e to the y is just itself, but you need to consider the sign of the exponent just because of the chain rule. That's why the antiderivative of this would be just e to the negative y, but times -1 just because the derivative of this exponent, okay, equals x cubed minus 3x squared plus c. So let's go ahead and plug in our initial condition to get c right here. So negative e to the 0 equals 1 cubed minus 3 times 1 squared plus c. So I have -1, 1 minus 3, -2 plus c. So c is going to be 1. So the rest is pretty easy. You just go ahead and plug in your c, and it becomes negative e to the negative y equals x cubed minus 3x squared plus 1. And then you can multiply each side by negative. This will be negative e to the y. Sorry, e to the negative y is going to be negative x cubed minus 3x squared plus 1. And finally, if you take ln of each side of the equation, then you will get negative y down here, right? So that will be ln negative x cubed plus 3x squared minus 1. And then you multiply everything by -1 again. Y is going to be negative ln negative x cubed plus 3x squared minus 1. Okay? You can just work with this and then move on to a more simplified or one more step simplified version, but you don't have to. So this will be an enough answer in AP exam. And remember, just a side note, in your AP exam, you need to keep your answers unsimplified. You don't have to, but it's better to avoid some arithmetical mistakes that might happen, not related to calculus, but you can lose points because of those. Okay, let's go ahead and look at our last question. So this is 2014 AP exam question. We're going to find a particular solution again with the initial condition f of 0 equals 1. So let me write my equation first. 3 minus y times cosine x. So let's separate the variables. So this is going to be dy over 3 minus y equals cosine x dx. We just go ahead and take the antiderivative of each side. So just be careful here with 3 minus y. Yes, I know that this is going to be ln 3 minus y, but this is a negative ln 3 minus y. You guys be careful with the chain rule here, okay? And equals sine x plus c. Let's go ahead and make this a better look. So it's going to be ln 3 minus y equals negative sine x plus c. I don't have to make my constant c here negative because whatever the sign of the number here will be nc. So it doesn't matter you have a negative or positive here. Just keep it positive. Just keep it c, okay? And then this is going to be e to the negative sine x plus c. So this is the same as 3 minus y equals c times e to the negative sine x, right? So go ahead and plug in your initial condition here. So it's going to be 3 minus 1 equals c e to the negative sine 0. You already know this means just a 0. So 2 equals c. Then go ahead and write your final solution using c. This is going to be 3 minus y equals 2 times e to the negative sine x. So it's same as 3 minus 2e to the negative sine x. Okay, we're all done. Thanks for watching. You can find the blank version of these questions and the completed solutions below as a PDF attachment. If you have any questions, please write as a comment below. I'll try my best to answer them. Bye.